Hello and welcome to the latest video on this How to Code a Game Like Minecraft in Unity series. I'm sorry this video is a little bit late, as you may be able to tell by my voice. I'm not in the best of states right now, but I'm actually going away this weekend, so if I didn't get this video done now, there probably wouldn't be a video this week, so we're going to power through. So this video is going to be on threading. It was originally going to be a video on general optimization, just generally making everything a little bit faster. I've had to scrap the rest of it because one, threading is quite a complicated subject, and as I've mentioned before, is a bit beyond what I'd intended for this channel, and also it would make it a longer video, and I'm not sure I can talk for that long at the minute. So we're just gonna implement threading in this video, and I'm gonna save some of the other optimizations for another video, and we'll just have like a general optimizations and bug fixes video. So let's get straight into it. So there's a few things we need to understand about threading, and this is not going to be a comprehensive tutorial on threading. I am not qualified to give a comprehensive tutorial on threading. This is just going to be the roughest of basics in order to understand why we're doing what we're going to be doing. But basically, threading, if you don't know, is using a separate... So you have your main thread, which is what all your update and all these functions, everything that we're doing currently, explicitly, everything that we're doing is running on one single thread. Maybe Unity is doing some stuff on other threads in the background, I don't know. I'm not entirely sure how Unity handles stuff. It's probably using other threads for things like graphics and that, but we're using one thread. Everything we're doing is on one thread. One way that you can sort of think of threading is in the coroutines, which is still using one thread, but what it's doing is it's breaking stuff up so you can run two functions simultaneously. Well, it's not simultaneously. It's running one function and then breaking out and then coming back to it, and like moving a step at a time and then coming back to it and then breaking out again and so on. Threading would be running that function on a completely separate processor core. So that function can do whatever it wants, and it completely does not affect your main thread. So if you were to put a while loop that has no way of breaking out in your main thread, it would cause Unity to hang, and you'd have to Control-Alt-Delete out because there'd be no way of stopping it. If all you had was a while loop, no code in it that would allow you to break out of that while loop, and it would just carry on looping forever until you ended the task in Windows or whatever software operating system you're using. If you put that while loop in a separate thread, it would not cause your main thread to hang up. Don't do that, by the way. Yeah, like there is issue. Threading can be very dangerous in terms of like you're running your program properly. But if you did have that while loop, that pointless while loop on a separate thread, you would be able to continue using your main thread without any issue. So that's the advantage. The disadvantage is, well, the first thing is that there is no error reporting on other threads. So you only get if I just type some random gobbledygook here and then go here, you'll see that we get this error. Obviously this error would still show up even if it was on a separate thread, because that's just a syntax error. But if there was an error during runtime, like I don't know, index out of range or a null reference exception, something like that, and it happened on another thread, we would never see that error report. So if you have something wrong with your code that you are running on another thread, you've really got no way of knowing what the problem is. You'll just see the end result on the screen in the game. You won't actually get an error that will tell you why it's done what it's done. So that's the first thing. The second thing is that Unity is not what we call thread safe, which means that it's barred from being used. Anything that's Unity specific, with a few exceptions, is basically barred from being used on a separate thread. So if we created a new thread and we tried to create a new game object in that thread, Unity would just say no. Unity have put these checks in place to make sure that we don't try and do that, rather than just letting us do it and finding out the hard way that it doesn't work. So there are some exceptions, like vector 3s and vector 2s and all that, some data types. They work fine, but things like meshes don't work. So you might see the problem that we're going to encounter there, which is the main thing that we're going to want to do with our thread is to handle the mesh creation. Where was it? Down here. So one of the most time-consuming parts of what we are doing is creating the mesh, which we cannot do in our thread because meshes don't work on a separate thread. Now at this point you might notice that we actually did quite a bit of separation between mesh and data for this reason, in case this ever came up. This is why you've got your create mesh here and you've got all this here. And this is just adding vertices, vector 3s and vector 2s and integers into sublists. So that could be anything as far as Unity is concerned. It's only when we run this function that it finds out that all these lists we were creating are mesh data. And then we put them into the actual mesh. So this function we can thread. This function we can't. So that's the next thing. In terms of problems, basically it's just Unity, not thread safe, and no error reporting. So we need to make sure our code works. So the things that we need to do to make sure that it is going to work. Firstly, we're going to create a new bool just below here, and this one is going to be called public bool is, thread locked. It's going to equal false. And then somewhere down here, I think of a good place to put it. We'll go here. We're going to create a new public bool, and this one is going to be a get bool, and this is just going to be is editable. And then all we're going to do is if is voxel map populated. Sorry, if voxel map is not populated or we are thread locked, return false, else return true. So basically, instead of checking whether our voxel map is populated before deciding whether we can do anything with this chunk, we're just going to have this is editable, and then any qualification we want to put, any validation before we edit this chunk, we can put in this bool here. So if further down the line we have some other variable we want to check before we allow anything else to edit this chunk, we can put it in here. So to that end, we need to go into our world script and, if we go back in here and we make, let's make these private. And we should have some errors. We'll just give it a chance to update. There we go. And then we're just going to swap these to is editable. And just make sure that that is all of them. I don't think there was any other references to it. Yep, okay. So the next thing is that one of the Unity components that is not thread safe is transforms, which we are currently using. Where is it? Here. So this is not going to work because we are going to be calling on our transform on our position from our threaded function, and that means that it's going to be trying to access the chunk object's transform from our threaded function, which will not work. So, I mean, this was an unnecessarily flashy way of doing this anyway, so we're just going to get rid of that, and then we will just do it the far simpler way that we should have done in the first place. We'll just create a public vector3 position, and then when we initialize, we will set that public vector3 position to our chunk object's position. And there is one thing that I noticed when I was working this all out is that for some reason, we'll just find it, in our get voxel here, for some reason I was calling chunk object transform when obviously we have our position. So we'll just change that. So now it's using our stored vector3. Next thing we're going to do, head over to world, and we're going to create a new list up here somewhere. Not a list, sorry, a queue. And this queue is going to be a queue of chunks, and it's going to be called chunks to draw. Now, back into it. There's going to be a lot of just code in this one, but it's unavoidable. So, if we find our update chunk, this is one of the perils of not doing particularly clean code, is having to find everything like this. But unfortunately, this is a bit of a Frankenstein project. I only planned so far in ahead when I first started the series. I didn't expect it to be as popular as it is. So I'm kind of making this up video to video at this point. So we're gonna make this private, and we're gonna rename it update chunk, and then we're gonna just for the time being, create a new void to replace that. which for now we'll just call update chunk, but obviously we will be doing something else with it. This update here is going to be our threaded. This is all going to be run on a separate thread. So the first thing we're going to do is set thread lock to true. So this makes, once this update starts running, this makes this chunk uneditable, because all our checks before we can do anything with this chunk, check to see if it's editable. Now that we've set thread lock to true, is editable is going to return false. So once we enter this function, this chunk becomes no bueno, no touchy. The next thing we're going to do is we're going to get rid of create mesh, because like I say, this is running on a separate thread. We cannot create mesh on a separate thread. And what we're going to do instead is we're going to add this. Oh, sorry. I need to make this queue that I created public. We're going to add this chunk to the trunks to draw list. Of course, it helps if you use the proper function. There is a problem, another problem that arises from threading, and that is there's possibly a way, but I'm not entirely sure. It was above my skill level if it is. But as far as I'm aware, there is no way of properly determining when threading stuff will happen. So what that means is I can't accurately say if chunk 01 will get to this line of code before chunk 02. So you're gonna have more than one chunk running code at the same time. I can't say which one's going to get to try and add stuff to the queue first, and if you have stuff trying to add at the same time, it causes problems. And basically, if I just leave this like this, what you end up with is like a patchwork of missing chunks, which they've all been generated and stuff, but they don't all get drawn, and then they will pop into existence if you edit them in the game, if you place a block or whatever. Obviously that's not ideal. So the way we get around this is we lock it. So if we lock the actual list, and you can use any object for this, I'm just choosing to use this for the sake of, because it's the thing that we're actually editing, so it makes sense. And what this does is as soon as it gets to this line of code, it checks to see if it's locked. If it's locked, it waits. If it's not locked, it locks it, and then it runs this line of code. And then it gets to here and it unlocks it. So what it means is that only one thing can access this at the same time. And we will have to do this in the world script, obviously, to make sure. And then once we've done all that, we can put thread locked equals false. Our chunk is now editable again. Now, if we go back to our update chunk, we'll get rid of that. And we're going to have this start a thread instead of just call the function. So the way, first off, we need to bring in using system.threading. And then in here, we start a thread. Now, I'm going to create a thread and store it, but you don't really need to do this. You could do it like this, new thread, and then you want thread start, and then we put in our function. And then you could just put start. And then that would, oh, 1 second, sorry. You need to put a new here. And then that would start the thread. But there's no reference that you can keep to this. So we're not going to need it in this video, but just for the sake of getting you into the habit of it, because I think it's better practice than not doing it, we're going to put this into its own reference. So we'll just call it thread my thread equals new blah blah blah, and then below that my thread dot start. So this will start the thread, which is this function here, and then from that point on, anything that is done as a result will be on the separate thread. So even though we're only starting this function on our separate thread, it's calling update mesh data, it's calling, I think that's the only thing on this one, it's calling get update mesh data. But the point is, any functions or anything that get called from here will be done on the separate thread, which is why we had to change the position value, the position vector 3 that we had, because as you can see, that is used here. So even though that's a separate function, we had to change it because this was going to call it, and that would have been on another thread, and you can't call call a transform from another thread, because that's a Unity not thread safe thing. So that is the update chunk part, and also we want this to run on a separate thread as well, because we don't want anything, we want as little as possible hanging up the main thread. So for this one, we're going to go up here, and we're going to do exactly the same thing. Only this time it's going to be populate voxel map. And we're going to get rid of these. We don't need update chunk, and we don't need populate voxel map. We don't need update chunk because we're going to handle that in the world script, and we don't need populate voxel map because that's what we're doing here. So I think that's everything we need to do in our chunk. Now it's just going to get a little bit tricky in here, because for the sake of right now we have the voxel modifications. Queue is just a lot of modifications because it's adding them one at a time. I'm going to change that so that we're adding individual structures to the queue. So, and the way we're going to do that is we're going to make it a queue of voxel mod queues, which is getting a bit inception-y, but bear with me. So if we just create this queue here like this, and then enclose these here. So basically it's a queue of queues. So within this queue we are storing queues of voxel mods. This is obviously going to require some changes elsewhere. For now we just need to go into our structure. Instead of taking in a queue to edit, we're just going to have it return a queue. So at the top here we'll put queue, nope, sorry. Queue voxel mod queue equals new queue. So the rest of this is just going to operate the way it did before. It's using the queue that we've created here rather than one that we've passed in. And then at the very end, we're just going to return that queue. And then back in our world script, we're going to have to edit everything to accommodate this. So the first thing we're going to do is we're getting rid of all this. Now that we're doing it in threading, we're just going to handle it all at the same time. So in generate world, all we're going to be doing is creating the chunks. And then down here in apply modifications, this one we actually want to modify to work with the new queue. So firstly, make this a void, because we're not going to be running it as a numerator anymore. And we're going to get rid of count, because we don't need that. And then basically the way we're going to do it is we're going to have two while loops. Sorry, just get rid of that. One while loop for the overall modification count, and one while loop for the individual queues within that modifications queue. So the easiest way is to just basically intercept everything. So we're going to go create a new queue here. Voxel mod queue equals modifications.dq, and then we're going to loop through that queue here. So while queue.count is greater than 0, and then we're just going to enclose all of this. And then this now becomes queue instead of modifications, and all the rest of it just runs the same way it ran before. So it's just looping through two sets, but what it means is that structure here, instead of returning one voxel at a time, is going to return the entire structure as a queue. Oh, what have we done wrong here? Oh, sorry. Need to specify the type of queue. Yeah, instead of returning a voxel at a time, is going to return the actual, or instead of adding a voxel at a time to the queue, is just going to return the whole structure, so in this case the whole tree, in one queue, and add it to the queue of queues that we've created. So the last thing I think we need to do, and I realise this has been a bit of a boring video to stare at, is we need to go in here, and obviously that's not a coroutine anymore. So we're just going to call apply modifications the same way we do with the other ones. We don't actually need this check here, because in our apply modifications we're immediately doing a while modification count is greater than 0. So if we get to here and modification count is less than 0 or is less than 1, then it's just going to skip over all this and get to here. So we don't actually need that check. And then we need to add our new chunks to draw thing. Now this isn't quite as simple as the others. And the reason for that is, well, first off, let's just do a straightforward check. Chunks to draw dot count is greater than 0. So if we have any chunks to draw, we need to lock the queue as mentioned, because we don't want anything else changing the queue while we're looking at it. Chunks to draw. And then in that lock, we need to do a check. Now, you have to check a queue in a special way, because as you know, dequeue removes the item from the list. So we have to look at the queue without removing that item, and the way we can do that is if chunks to draw dot peak, so that's going to peak at the next item that would be removed if we used dequeue dot is editable. So it's only going to do anything if the next item is editable. If it's not editable, it's just going to pass over it and it will have another go on the next frame. And if it's editable, we're going to create mesh or not. We haven't made our create mesh function public, have we? No, we have not. Yeah, we're going to need to make this public. So so this bit of code, it will look at the next item in the queue if it's editable without removing it. If it's editable, it will dequeue it, so that will remove it, and it will run the create mesh function on that chunk. The create mesh function obviously is just creating the mesh, because if it's been added to the chunks to draw list, that means that it has already had any updates that it needed doing done to it. And speaking of updates, somewhere down here, don't think we need to do anything to the chunks to update. Yeah, that's in the chunks to update. It's going to check that it's editable, and then it's going to run the update chunk function, which, as we know, now starts a separate thread, does all its stuff, and then once it gets to the end of that thread, it's going to add it to the chunks to draw list, and then when the chunks to draw part gets to it, it will draw the chunk. So in theory, I think that's everything. Oh yeah, we're not passing in this queue anymore. Okay, let's try it. Okay, well, obviously that's not right. So just give me 1 second, I'll figure out what I've done wrong. Oh right, yeah, sorry. When we run our populate voxel map, because we've taken out the update chunk reference from here, we're not actually updating the mesh data and thus telling the chunk to be drawn. So we're not just going to call update chunk here. What we're going to do is we're going to call our threaded function update chunk there, and because we are running populate voxel map on another thread, this function will inherently be run on that same thread once it's done all this. So let's try that again. Okay. Incrementally improved. So we have our threaded chunk generation. As you can see, is barely any hit to the frame rate at all, but we appear to have lost trees. So once again, give me a second while I just figure out why. Okay, I'm going to put this down to being very, very poorly. But basically, we haven't added this. We've created this queue here. Structure returns a queue. So this function here is returning a queue, and we just haven't added it to our list. So modifications dot on queue, and then hopefully for the final time, let's run it, and we have our trees. Finally. I'm really sorry about this. I feel as bad as this video is going. So if I'll pull up our little debug window here. If we start running around now, you can see that the frame rate barely takes a dive every time we generate new chunks. And we can further optimize this, because obviously, because we're still creating the meshes in the main thread. There's nothing we can do about that. There are things we can do to optimize this further, which I will do in a future video. We're going to do some optimizations and various bug fixes and just general cleaning up. But basically, the main thing that we should be looking at when we get there is we are creating this, if I just find my player, yeah, we're creating this whole square around the player, which is entirely unnecessary. Like when we're generating our chunk view distance, if you look at the camera, if I just go to orthographic here, if you look at this, if you look at these lines here, that's your field of view for the camera. That's the only part that you can see. So all this round here is out of sight. So it's entirely unnecessary to be generating or loading or drawing these chunks over here when all you can see is this square here. So that's something we can look at in future. We can drastically reduce the number of chunks that we're having to handle at one time. And then when you add that to putting it on a separate thread and any other optimizations we can think of, you start to drastically reduce the amount of overhead that each individual update is running. So that's something to look forward to, but hopefully just simply putting it on another thread should make it a bit more usable for some of you, because I know some of you have been having trouble with the massive lag spikes that creating new chunks causes. But that's it for now. I'm sorry about the state of my throat in this video. Hopefully I'll be better next week. Next week is not going to be a Minecraft video. It's going to be whatever I can put together this week before Thursday, because like I say, I'm going away, and I'm going to be away when I would normally be uploading the video next week. So what's going to happen is I'm going to do the video this week and schedule it, and I won't be here. So and hopefully I will be a lot better by then. And then we'll be back to Minecraft video the week after. So comment below on what you would like the next Minecraft video to be about. I have an idea in my head as to what I think it should be, but if 20 of you all comment and say that you want it to be about a specific thing, I'll go with that, as long as it's in keeping with the actual series. I mean, I just remind everyone, I'm not teaching you here how to make Minecraft or how to make a polished game. This is just how to do the concepts behind Minecraft. I'm going to stop rambling now because my throat feels like I've been swallowing sawdust, and I will see you next week. Bye bye. Bleep. Sorry, one last thing. In our edit voxel here, we want this to call the update chunk, not the update chunk, because the update chunk is threaded. We don't want our edit voxel to be held up by threading queues or anything like that, because when we call edit voxel, that means the player has edited the chunk and those chunks take priority. So for that, we want our chunk updated immediately on the main thread so that it's done straight away. So just change this one to call the update chunk, and this, because we're calling it from here, it will be outside of the main, it will be used in the main thread. Back to finishing the video.